So let us look at question number 51 now, students. What volume of 0.5 molar HNO3 is required to completely dissolve 13 gram of zinc according to the balance equation? So we have to assume that HNO3 is converted into NO2 and the molar mass of zinc is given to us, which is 65 gram per mole. So students, if we figure out the moles of zinc which is given to us, so N of Zn, it is equal to the given mass upon the molar mass, so which comes out to be equal to 0.2. Now if we talk about the redox reaction going on, so we have the zinc getting oxidized, it will convert into zinc 2 plus, which is the stable oxidation state of zinc, and it will lose 2 electrons. Whereas if we talk about the nitrate ion, the NO3 minus will convert into NO2. Now if we try and balance this half reaction, we have 1 H2O and we have 2 H plus, and then we have an electron at the left. So we have to multiply this second reaction by 2 in order for the electrons to get cancelled. And if we try and balance the reaction, we have zinc plus 2NO3 minus plus 4H plus, giving us zinc 2 plus plus 2NO2 plus 2H2. Now students, this is the ionic form of the expression. We have to convert it into the molecular form. So for molecular form, we have to just counter these ions present inside the system. So we have zinc 2 plus present in the product side. They shall be countered by 2 nitrate ions. And if we talk about the 2 nitrate ions on the left, they won't be able to counter the 4 positive ions. So the addition of 2 nitrate ions on both sides of the reaction is going to convert this ionic form completely into the molecular form. So we'll have Zn plus 4HNO3 converting into zinc nitrate, which is ZnNO3 whole twice, plus 2NO2 plus 2H2. So students, we can see that 1 mole of zinc require 4 mole of HNO3 in the balance reaction. So we have 0.2 moles of zinc, which means that we should have 0.8 moles of nitric acid, and this is coming from a 0.5 molar solution. So we have 0.8 equal to 0.5 into V, where V is in liters. And on solving for the value of V, we have V equal to 1.6 liters. So students, the correct answer to this question is option 4. Let us look at the next question now. Question 52. A metal has 2 stable oxidation states A and B. The metal is converted into its lower oxidation state Ma positive by concentrated H2SO4 and further oxidized to its higher oxidation state, which is Mb positive, by KMnO4. So it is given to us that 0.4 moles of the metal liberated 8.96 liters of H2 at STP on reaction with H2SO4 to form Ma positive, and further required 40 ml of 2 molar KMnO4 in acidic medium to form Mb positive. We have to comment on the value of A plus B. So students, if we try and tabulate the data which is given to us, so we have M, which is allowed to react with H2SO4 and converted into Ma positive plus hydrogen is liberated. So this Ma positive is now further allowed to react with KMnO4 and it is converted into Mb positive. So the KMnO4 gets converted into Mn2 plus in the acidic medium. So we can have the N factor of KMnO4, which is equal to 5. And if we talk about the information about H2 given to us, the volume liberated is 8.96. So we can have the moles by dividing it by 22.4. So this comes out to be equal to 0.4 moles. The moles of the metal initially given to us is also 0.4. So students, if we try and equate the gram equivalents of the metal M to the gram equivalents of H2, we know that they are both going to be equal. So we have GMEQ of M equal to GMEQ of H2. So H2 has an N factor equal to 2 and the moles formed are 0.4. Now if we talk about the gram equivalent of metal M, we have 0.4 moles into the N factor, let's call it as X, So zero point 0.4 into x shall be equal to 2 into 0.4, which implies that x is equal to 2. So we can see that the value of A should be equal to 2 and the state of this metal should be M2 positive. So in order to solve for the value of B, we can now use the KMnO4 data which is given to us. So we had seen that the KMnO4 had an N factor equal to 5 and the millimoles have been given to us. So it is told to us that 40 ml of KMnO4 is required, which is 2 molar in it. So we have 40 into 2 into 5. So this is the milliequivalents. We have to divide this by 1000 for it to give us a value of equal to gram equivalent. So this should be equal to 0.4, which is the moles of the metal, and the N factor. Let's call it as Y. So on solving this expression, we'll have the value of Y equal to 1. Now if we talk about the N factor in this expression, this Y, it can be written as equal to B minus A, as it was initially present in a state of A positive and it has converted into a state of B positive. So we have Y equal to B minus A, which is equal to 1. And we know that the value of A is equal to 2, as we had already seen before. So this means that the value of B must be equal to 3. So the value of A is 2 and the value of B is 3. And the examiner is interested in the value of A plus B, which comes out to be equal to 5. So students, we have to mark option 2 as the correct answer to our question. Let us look at the next question now, question 53. Which of the following will cause the dissociation equilibrium of CaCO3 to shift in the forward direction? Students, we have CaCO3 solid converting into CaO, which is also solid, plus CO2 gaseous. So if you look at the first statement, addition of CaCO3 solid. So students, addition of CaCO3 will not cause any disturbance in the equilibrium. And also the removal of CaO shall not cause any disturbance because the concentration of the solid remain constant during the course of the reaction. So it does not matter if we add or remove any solid components, the equilibrium is not generally disturbed. If you look at the third statement now, the examiner has told us that there is addition of helium at constant pressure. So at constant pressure, the addition of helium will lead to an increase in volume. So in order to nullify this effect, the system will move in the direction of more number of gaseous moles. So students, the process mentioned in statement 3 will indeed cause the equilibrium to shift in the forward direction. So this is correct. If you look at the fourth option now, increasing the temperature. So students, increasing the temperature will lead to an increase in the dissociation constant of the solid, as the delta H of this reaction is positive. So students, it will also lead to the shifting of the equilibrium in the forward direction. So students, we have to select those options which cause the dissociation equilibrium to shift in the forward direction, and we have to mark option 3 as the correct answer to our question. Let us look at question number 54 now. So we have been given a sequence of reaction in which we are starting with 1122 tetrachloroethane. So we have 1122 tetrachloroethane, which is allowed to react with zinc. So zinc is going to cause dehalogenation in this case and will have the formation of acetylene, which is the product R. Now this R is subjected to undergo reaction with red hot copper. So it is going to form benzene. Now, which is the product A. Now benzene is allowed to undergo nitration with HNO3 and H2SO4. So we have nitrobenzene as B. And now when this nitrobenzene is subjected to bromination, we are going to have a meta-substituted product. So students, we have the structure of C, which is correctly given in the second option. So students, we have to mark option 2 as the correct answer to question number 54. Let us look at question number 55 now. The BOD of 4 water sample A, B, C and D having value of 5 ppm, 12 ppm, 8 ppm and 17 ppm respectively. Out of the following, the least polluted water is. So students, we know that higher the value of BOD, greater is the pollution level inside the water sample. So if we talk about the pollution level in these water samples, we have A as the least polluted, followed by C, followed by B, and then the sample D is the most polluted water sample. So as we move from left to right along this, in this order, we have the pollution level increasing. So we have to select the least polluted water sample. So we have to select 1 as the correct answer to our question. Let us look at the next question now.